Welcome to The Explainer. Today we're going to talk about what is, quite possibly, the single most important invention of the 20th century. It's a little device that is literally everywhere you look, but you can't see it at all.
So let's start with a question. What's that one fundamental little piece of magic that powers everything? I mean, everything, from the phone in your hand to the computer in your car.
Well, you might think it's a microchip, or maybe some fancy line of code. But the real answer? It's much, much simpler than that. It's basically a perfect little switch, a switch with zero moving parts that can flick on and off billions of times a second. Just think about that.
And when I say tiny, I really mean it. We're talking about a process that's almost like printing with light. And with it, we can cram billions of these tiny switches onto a single chip of silicon that's about the size of your fingernail. Billions.
Okay, so what is this thing? It's called a transistor. And the big question is, how does this one tiny component manage to run our entire digital world? So, at its heart, a transistor is just a really, really good electronic switch. The cool part is, it uses a tiny little bit of electricity to control a much bigger flow of electricity. It can be all the way on, all the way off, or, and this is key, somewhere in between.
You know, the easiest way to wrap your head around this is with a simple analogy. Just picture electricity as water flowing through a pipe. The transistor? That's just a valve, like a faucet handle, that you can use to control how much water gets through.
Okay, so a tiny little electrical signal, just a little nudge to the transistor's control pin or its base, is just like you turning the handle on that valve. Give it a small turn and you can open the floodgates and let the main current flow completely. That's saturation mode. Or you can shut it off tight, stopping everything. That's cutoff mode. But what's really cool is that you can also open it just a little bit, precisely controlling the flow. And that's how it works as an amplifier.
All right, so it's a switch. Big deal, right? But how do we get from a simple on-off switch to something that can, think? Well, this is where it gets really amazing.
It's all about how you link them together. See, when you start combining these little transistor switches in clever patterns, you create what are called logic gates. And this is the leap. This is how we go from a dumb switch to the actual building blocks of a computer.
So let me break down the two most basic logic gates for you with this great little dinner analogy. First, you've got an AND gate. That's like saying, I'll go to dinner if Bob and Terry are both going. Both things have to be true for you to go. Then there's the OR gate, which is way more chill. That's like, if Bob or Terry wants to go, I'm in. See, only one of them needs to be true. And believe it or not, that's the heart of all computing right there. You just chain together millions or even billions of these simple if this, then that decisions. And suddenly, a machine can do math, it can process information, it can run all the software that basically powers our entire world. But to really, truly appreciate how revolutionary the transistor was, we have to take a quick step back in time. Let's look at what the world was like before it came along. Because the first computers, they were powered by something completely different.
Yeah. For the first half of the 20th century, computers ran on these things called vacuum tubes. Now, they did the same basic job as a transistor. They could switch and amplify signals, but they were basically just big, hot, fragile light bulbs made of glass. Not exactly ideal.
And when you compare the two side by side, wow, the difference is just night and day. Transistors are microscopic. They barely sip power, they're super reliable, and you can make them for next to nothing. Vacuum tubes, literally the exact opposite on every single one of those points. Let's put this in perspective. Get this, if you tried to build a modern Intel processor using old-school vacuum tubes, you need a building that was 13 stories high and almost a mile long just to house it. So yeah, the whole idea of personal computing, absolutely impossible without the transistor. It just wasn't going to happen.
So this new power to make electronics tiny, you'd think its first big splash would be a computer, right? No, the first thing that really changed the world was something much simpler, something you could hold in your hand, a pocket radio.
The transistor was actually invented way back in 1947, but it took a little while to go from secret military tech to something you could buy in a store. But then, in November 1954, the Regency TR-1 radio hit the shelves right before the holidays. And, well, it became the gift to get that year. You have to remember what radio was like back then. It wasn't personal. Radios were these huge pieces of furniture that sat in the living room. Listening to music was a family thing. Everyone had to gather around the one machine to hear it.
And then, this little thing comes along and changes everything. All of a sudden, music was personal. It was portable. For the very first time in history, teenagers could take their music, and listen to it wherever they wanted, away from their parents. This little box basically fueled the entire rock and roll revolution of the 50s.
So, starting with that one little radio, the transistor's impact just exploded. It started with music, sure, but it quickly became about everything else. It was about building the world we live in today, one tiny switch at a time.
The legacy is just incredible. The transistor enabled integrated circuits, bundling millions of switches together. That paved the way for the first personal computers. And that, of course, led to the mobile phones and smartphones we can't live without. It is, without a doubt, the fundamental component of our entire digital age. So this one tiny switch put a computer in your pocket and made technology personal. It completely changed how we live. And that kind of leaves us with one final big question to think about. If the transistor made computing personal, what's going to happen when the next big invention makes it completely invisible?